I am Professor Dr. D.N. Zambre, Head Department of Chemistry, Kisan Veer Mahavidyalaya, Y. There are different types of the solvents. Now we are going to discuss some definition and characteristics of the solvent. For example, in case of solvent, the water is called as a universal solvent. Why? Because many types of the reactions in the research since morning up to the sleep, every time we are going to use the water as a solvent. In case of water, each and every compound, chemical, whatever that solute get dissolved in water. That's why water is called as a universal solvent. But number of reactions that is highly impossible to carry out in the water that can be carried out in the non-aqueous solvent. That's why different types of the solvents are there. For example, if you see, the solvent may be classified in the number of ways. It means here protonic solvent and non-protonic solvent, that is also called as a aprotic solvent. It means protonic solvent is having the tendency to donate the proton. And for example, HF, H2SO4, HCN, CS3, COOH, acetic acid, C6H5OH, all these are called as the protonic solvent. Protonic solvents are basic type in nature, solvents are aprotic type of nature, and solvents are amphiprotic type of nature. If you see here, the classification of solvent neatly in the form of first protonic solvents and aprotonic solvent, or that is also called as a non-protonic solvent. Protonic solvent, it is nothing but solvent which is having H plus ion, that is called as a proton. Proton, it is nothing but H plus. For example, hydrochloric acid, for example, sulfuric acid, for example, HF, nitric acid, each and every acid having H plus ion. That's why first category here we are going to discuss about acidic solvent. Acidic solvent, it is nothing but acetic acid, HF, H2SO4, HNO3, all types of the acids when it mixed with the water in the aqueous media, there is a formation of H plus ion. Proton get released. That's why these all solvents are called as a protonic solvent. Then second one is the basic solvent. Protonic solvent are divided in acidic solvent, basic solvent, and amphoteric solvent. This is the first acidic solvent. This is the second acidic solvent. Basic solvent. Basic solvent which is having basic in nature. It means to have the tendency to accept the proton. It is the basic nature. According to the Bronsted-Lowry concept, base is defined as when any substance which can accept the proton is called as a base. It means here basic solvent like liquid ammonia, ethylene, diamine, C6H5NH2, which have the tendency to accept the proton. And here acidic solvent, it is having to tendency to donate the proton. It means this proton can be easily donated to another species. And this ammonia, that H plus when combined with NH3, here NH4 plus formation takes place. It means proton can be easily accepted by this ammonia and the formation of NH4 plus ion takes place. That's why it is having tendency to accept the proton, and this is coming under the category of basic solvent. Third one is the amphoteric nature. Amphoteric or amphoprotic. What is meant by amphoteric nature or amphoprotic nature? That is nothing but having tendency to accept as well as having tendency to donate the proton is called as the amphoteric nature. For example, if you take H2, water having tendency to accept a proton from that hydrochloric acid, and there is a formation of H3O plus. Same water, when if you consider in the next reaction, here what happened, that one proton can be donated to this species and the formation of NH4 plus ion takes place. It means in first reaction, having tendency to donate the accept the proton, that is the water is acting as a base. Here in second reaction, what happen? Having tendency to donate the proton, that's why H2O is acting as a acid. It means in same substance in one reaction acting as acid and in same substance in another reaction acting as a base is called as a amphoteric nature. Second type is the aprotic solvent or non-protonic solvent. Aprotic solvent, it is nothing but there is the absence of proton, and non-protonic solvent, it is also nothing but there is the absence of proton. For example, aprotic solvents are again divided in particular three parts: non-polar, non-dissociated liquid, that is nothing but which do not solvate strongly, like CCl4, hydrocarbon. CCl4, it is nothing but carbon tetrachloride. It cannot dissociate. Even though if you take benzene, benzene also cannot get dissociated. That's why this is coming under the category of non-polar or non-dissociated liquid. It means here the main characteristic is the low polarity, then low dielectric constant, poor donor power, and no self-ionizing capacity. These are the properties of a non-polar, non-dissociated liquid. Then second one is the non-ionized, non-dissociated but strongly solvated solvent like CH3CN, DMF, DMFSO, and SO2. They are mainly aprotic because the protons are totally absent here. That's why this is called as a aprotic solvent. It means some of the solvents like DMSO have high dielectric constant. Here some have low dielectric constant, and these having solvent or solvated properties. Cations best only by using negatively charged oxygen atom. Then third one is the highly polar ionizing solvent. Highly polar ionizing solvent, it is nothing but itself get ionized. For example, if you take BrF3, when combined with BrF3, it is giving rise to BrF2 and BrF4. It means here H2O, BrF3, IF6, such solvents are auto-ionized. It get ionized itself. Then next type is the ionizing and non-ionizing solvent. Ionizing solvent again explain in the form of they undergo auto-ionization and bring about the ionization of the solute. These are polar in nature. These are polar in nature. What is by polar in nature? Polar in nature, it is nothing but when in any aqueous solvent, it get releases positive and negative charges. Two parameters get released. That's why it is called as a ionizing solvent. This having high dipole moment, dielectric constant, both are high. Then good solvents for ionizing solutes, example water, liquid, hydrogen fluoride, NH3 are the good ionic solvent. In second, non-ionizing solvent, they are undergo auto-ionization, do not bring about the ionization solute. These are non-polar because poles cannot get formed. Negative and positive poles are not formed in this particular solvent. They are suitable for only covalent compounds. Next, physical. Thank you.